I'm here with Keith Mansfield at the Centre for Mathematical Sciences in Cambridge. Would you like to introduce yourself, Keith?
Of course. So I'm Keith Mansfield and I studied mathematics here at Cambridge. And then my career since doing that has probably been a bit different from many mathematicians and has gone into books. And so I write a series of science fiction books, but they're quite full of mathematics and science. And I also publish other people's books on mathematics and science. Until recently, I was the maths publisher for Oxford University Press. And since leaving there, I helped come up with the ideas for a new TV series called It's Not Rocket Science. So these are some of the fun things that mathematics can do for you.
Sounds pretty exciting.
Uh-huh.
And what is it that you like most about doing mathematics?
So, I love that if you can do mathematics, it sort of makes you special. It gives you special abilities or powers that not everybody seems able to do. So it's like almost being a superhero with those sorts of special powers. The way you think can be quite different from other people sometimes and give you advantages in all sorts of areas of life. But in terms of how you think about things, for instance, most people, if they think about the world around them, they might think it exists in 3 dimensions, or if they think particularly deeply about the world around them, they might think it's 4 dimensions because you have 3 space dimensions and then time. But if you study mathematics, you learn to think in many higher dimensions than that, which is really fascinating. And some problems that you deal with, you actually work in infinite dimensions, infinite dimensional space, which is just mind-boggling and really difficult for someone who doesn't know mathematics to be able to comprehend. But using that kind of level of thinking, you can then get very clever solutions to real-world problems in the here and now. So maths is a very powerful tool. I like the way that maths is the way that knowledge can progress. And it can give you more solid foundations to base your knowledge on. If you don't think mathematically and weigh arguments mathematically, then it's more about opinions. But using maths, you can decide which opinions are better. For instance, a very famous mathematician, Isaac Newton, came up with his theory of gravity, which was an amazing theory and predicted a lot of things about the world. But then Albert Einstein came up with a very different theory of gravity, and which is right. Is it Newton? Is it Einstein? But Einstein had a very unusual prediction that light, even though it doesn't weigh anything, light rays will be bent by gravity, and someone could test that. They could measure how much the sun bent starlight around it, and they found not only was the starlight bent, but it was bent exactly by the amount predicted in Einstein's theory from the mathematical equations. And so we know that Einstein's theory takes us a step beyond Newton's theory, and that's a great way for knowledge progressing through mathematics.
So there's a big role for maths in the future of humanity. But what about you? So. What is your own personal mathematical moment? Can you describe one?
So for me, a special moment in mathematics, if I think back to school, if I think back to my time in the 6th form, quite early on in the 6th form, actually a physics lesson, and people might think, why am I talking about physics when we're talking about maths? But Galileo said the universe is written in the language of mathematics. And that's an amazing thing, and it means that applied mathematics is our way, it's basically our route into physics, and the two are almost interchangeable for me. And so I like to think about mathematical physics a lot. And back in the 6th form, the teacher said the next day we were going to be performing a famous experiment where we were going to measure the charge on an electron. And how do you measure the charge on an electron? And he said as a challenge, he said, I want you to go home and think, how would you do this? How would you solve that problem? And I thought that sounded quite an interesting problem. I wasn't doing anything that evening, so I started to think about it. And back in those days, and nowadays, we have flat TV screens, computer screens and phones, but back in those days, televisions were these tubes where we fired beams of electrons onto a screen and we manipulated them with magnets. And using that sort of technology, it's very easy to measure the mass to charge ratio of an electron, because you need that for where you're going to fire the electron. So that's quite an easy number to calculate. But how do you separate that out and get just the mass on its own, so then you could work out what the charge is? So I thought about that for a while, and then I realized one of the great mathematical theories is something called quantum mechanics, and it has lots of unusual consequences, and one is that particles like electrons sometimes behave like waves. And if you took your beam of electrons and you fired it at a very thin film, then what you'd get on the screen on the other side would be an interference pattern. So like if you look at waves in a pond and they're bouncing off the side and they're interacting with each other and they're interfering, it's the same sort of thing. And you could look at that interference pattern and you could calculate the wavelength of the electrons, and from that you could calculate the mass of the electrons. And so you could build a mathematical bridge from that experiment back across and work it and use the equation to work out what the charge on the electron was. So I was very pleased with that, and I wrote it all up in a nice way, and I took it into school the next day. And we got to the lesson, and there was no mention of this challenge the physics teacher had set the day before, and we just performed Robert Millikan's famous experiment for measuring the charge using oil drops, and the bell went. So I went up to the teacher, Mr. Russell, and I said, well, you said about thinking of our own experiment yesterday, and I came up with this, and I showed it him. And he looked a bit surprised, and it made me realize that not everybody was thinking about problems in this way. And he took my notes away, which now I'm a little disappointed about because I don't have that, and it would be quite interesting to look back on. But I like to hope that back in Nottingham, where I went to school, they're maybe doing Millikan's experiment, and then they're also doing the Mansfield experiment, and they're seeing which gets the better result for the charge on the electron. But it made me realize that if you can do mathematics, you can think in a way sometimes beyond people who can't do mathematics, and you come up with these interesting creative ideas. So I was pleased about that.
That's great. Thank you very much.
You're welcome.